So the first problem type we're going to be doing is expanding logs as a sum or difference of logarithms. This is really a calculus skill. And what I mean by that is this is something you will need to be able to do if you're taking calculus. We will not be doing this in the next section. We're going to be doing the other direction where I have many logarithms and I want to combine them into a single logarithm. But for calculus, you'll need to be able to do this. All right, the instructions say all powers should be written as factors. Simplify as much as possible. So meaning if there's a logarithm that you can evaluate without a calculator, then you need to do so. So expand the following. The first one is log base 3 of 81 x squared. All right, so I go to work this. Well, my logarithm rules say that a log of product is a sum of logs. So I'm first going to think of this as here's a something times a something else, right? So this is log base 3 of the first thing plus the second thing, not times. That's a really common mistake. Students will turn this into multiplication. Not the case. It's addition now. Okay. And so this is rule 1. I'm actually going to write what rule we're using here. Let's see. This is a number. We'll talk about what number it is here in a second. This one, well, all powers need to be written as factors. So I have another rule that lets me pull powers down as factors. So that guy is going to come out to the front. So this is 2 log base 3 of x. Okay, and that's rule 3. Now log base 3 of 81. So this is a number. 3 to what power is 81? Well, 3 squared is 9 and 9 squared is 81. So this is 4 because 3 to the 4th power is 81. So here's how I might think of that. Log base 3 of 81. 81 is 9 times 9, which is 3 times 3 times 3 times 3. So this thing equals 4. All right, so that's your final answer. 4 plus 2 log base 3 of x. For this one, natural log of 12 x to the 8 over y to the 9th. So there's a couple things happening. I have a quotient. So I have something divided by something. So I'm going to use rule 2 to rewrite this. So rule 2 says that a quotient of logs is a difference of, a log of quotient is a difference of logs. So log of quotient is a difference. So instead of having something over, I'm going to have log of the top minus log of the bottom. All right. Then in this one, I have a product because I have 12 times x to the 8. So that means I get to write log of first plus log of second. And then I still have log, oops, I wrote log instead of ln. In upper level math, we don't ever write ln, we just write log, but we actually mean natural log. So I will sometimes slip up on that. My apologies. All right, remember that this is L, not an I, ln, natural log. Okay, so log of the product, so that's the log of first plus the log of second minus this one. And then powers come down as factors. Powers come down as factors. So natural log of 12 plus the 8 times natural log of x minus 9 natural log of y. So before I box my answer, I have to ask, is there any way that I know natural log of 12? Well, I'd have to know the factors of the factors of 12, but I know that 12 does not have e as a factor. So this would be finished. Done. This was rule 3. Okay. Great. So very last one. This is probably the hardest one. These first two, no, not really on the first one. Just this one. You could have split up the numerator and then done the division, like then done subtraction, and that would have been fine. The biggest thing is that the power needs to go at the very, very, very end, because the third rule says something to a power equals, right? So if I pull this 8 out now to the front, well, that means that I'm multiplying log 12 and log x, but that's not what's written inside of my logarithm. Okay, so when I see this one, well, I've got a square root. I'm going to want to rewrite that square root as a power, because logarithms are about powers. Powers, 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 powers. So turn everything into a power. So x to the 7, p to the 9, q, and I know that the square root is the 1/2 power. All right, so here I have this. Now I've got anything that's multiplying, it turns into addition. Anything that's dividing turns into subtraction. Okay, so log of x to the 7 plus log of p to the 9th q, all to 1/2, minus log of e squared. So anything that was multiplying turns into addition. Anything that was dividing turns into subtraction. So that was rules 1 and 2. Now I can pull powers. Power, power, power. So that gives me 7 log x plus 1/2 log p to the 9th, p to the 9th q minus 2 natural log of e. Well, I know that natural log of e is 1 because e to what power is e? The first power. And again, here I have a log of product is going to turn into a sum of logs. So this is 7 natural log of x plus 1/2 natural log of p plus natural log of q. So log of the first plus log of the second. I have parentheses here because I need the 1/2 on both of them. And then minus 2. Okay. Final answer. 7 log x plus 1/2 log p plus 1/2 log q minus 2. And that's it. Now, if you had wanted to, oh, I forgot my 9. Whoops. All right, I forgot my 9 on my p. That comes to the front for that one. So this is actually 9/2 log p plus 1/2 log q. Now if you wanted, you could have distributed this power to the P and the Q and then pulled powers out as factors, that would have been fine as well. There's not a lot about the specific order things need to be done in. I would try and do powers out at, towards the end, unless the power's on the whole thing, which in this case it was. This is more of a calculus thing than an algebra thing. This is going to be done a lot in a calculus class. We're not really going to do it too much in this one. Rewrite square roots. Powers come down as factors. If you have a product, it's log first plus log second. If you have a quotient, it's log top minus log bottom. Make sure you keep the right log base. So here it's log base 3, 3, 3. Or natural log, natural log, natural log, natural log all the way down.